So let's start the lecture part of the Unix operating system course for this weekend. And I'm going to start out talking about Perl. And Perl is the theme of the first assignment for this course. Let me just go over the assignment first because before I started the video we had some questions about the first project. And some people had concerns about what kind of software they needed to install and stuff like that. So let me give you a little background on Perl before I start in on the official lecture for it and talk about this assignment to get everybody kind of familiar with what it is we're talking about. 'Cause sometimes if you don't know the big picture, it's hard to see the finer details. So let's talk about the big picture real quick. Perl is a scripting utility used in Unix. It's also available on MacBooks. So I see some of you actually have MacBooks. So you actually have Perl installed. You probably have never used it. So you can write little Perl scripts now and save them and actually make little desktop items out of them and run them. And they would back your system up. Or they would do something in terms of a utility on your system. So it usually runs, if you're not working on a Unix system, or even if you are working on a Unix system, usually runs in the form of an Apache server if you're running it through CGI, which is what this assignment's all about. I'll talk about Apache in a few minutes. Or it runs in its own command interpreter. So it's installed through what's called a command interpreter mode. And it's kind of like PHP, Python, Perl. They all kind of fall into the same category. They all run the same way. You can run them through Apache. You can run them outside of Apache. You can run them. They're all Unix tools, and they're all internet development tools. And believe it or not, Perl is used for a lot of internet development as well. So let me briefly go over the assignment, and then I'm going to start in so you see what you're working towards, and then I'll start in on the video, and so you can sort of see. I mean, on the lecture, you can sort of see Perl. And I forgot to pull my clock out. Hold on one second. I don't want to keep you guys running all day. Perfect. This will keep us so we've taken a reasonable break at a reasonable time. If I have reasonable time. So without a timepiece, I have no idea telling what's reasonable. So now I'm ready. All right, so what are you doing for the first assignment? You are assembling, and as I was mentioning before, I started the video to some of the students that were sitting here. It's hard for me to tell if you actually did this. And it's hard for you to tell if it's actually working until you have the proper development tools installed. So what you're doing in this first assignment, and this is the project number 1. If you haven't started it yet, it's not a bad idea to start working on this stuff because it's all due on May 1st. You're going to write a Perl script. You're going to run it through a CGI interface, and it's going to be a Hello World website, Hello World activity. So the concept is to investigate both CGI and Perl, and this is how Linux, Unix in the old days provided www support in terms of an Apache server. The Apache server is giving you the client server software. It's giving you the environment set up to be able to send and receive responses through HTTP. And the CGI interface, or the CGI gateway, is giving you that opportunity to come right into the server from the HTTP interface and run files and load utilities and do all sorts of activities on the server. So it was the gateway to the server, and I'll talk a little bit more about that towards the rest of this weekend here. But the purpose of the first assignment is to assemble. So you have a home directory. So this is the interesting thing, is this assumes you have Unix installed, and it assumes you have some sort of Apache or some sort of a server installed on your Ubuntu or on your Debian or whatever breed of Unix you're working with, or Linux. It's all compatible. Apache works on everything. In fact, you can even go out and get an Apache version for Windows. It runs on Windows XP and Windows 7. It's kind of a lot of memory. It takes up a lot of disk space. It takes up a lot of memory. If you have a MacBook, it's easy, actually. In fact, you already have a lightweight Apache server on there as well, so you don't have to install anything. So if you're a Windows user, you got to install a bunch of stuff to get this to work. If you're a Mac user, you have everything you need. So the point is, you're going to make a home directory called public_HTML. This home directory, you're going to give access rights to. I talked about this last time, actually, to make it public, which means people from the outside who are connected to your computer can take a look and access the files and things in here. Normally you would put HTML files in a public HTML directory. If you've taken web development, this is the common interface you're working with. All websites run the same way. From some server, there's a public HTML directory. It's usually divided out for users, and then you have domain names that go to each one of the IP addresses that are associated with each one of the locations on the directory tree that's associated with your subsection of this public HTML directory. So you're going to create a file, and the file is going to be called hello.pl, and it's going to have one line. It's going to print out, and this is a Perl. This is Perl syntax. It's hello world, essentially, for Perl. Prints out hello world. And then you're going to make a Perl executable. You're going to make the file executable. So, and you're going to do that by changing the access rights using a change mod command to give it executable capabilities. And today is all about scripting. So I'm going to talk about making files and scripts. And you don't even have to use Perl to make a script. You can actually just use a text editor, make a script. Give it the command line, using a change mod command, make it executable. And then when you type the name of the file, it's just like it's an exe file. It just runs for you automatically. So after you create the Perl file, you're going to run the Perl file. So if you're sitting here right now and you've got a MacBook and you go to a terminal prompt and you type Perl, and you get a bunch of, you left out an argument and, Perl documentation that shows up, that means you're set. Means you got Perl installed. You're not gonna, if you do that on a MacBook, on a MacBook it'll work. If you do it on a Windows box, it's not gonna work until you install Perl. There is a Windows interpreter for Perl. Actually, there's one for Python and PHP as well. But again, it's something you're gonna need to install. Otherwise, if you typed in Perl space hello.pl, it's gonna print out essentially hello world, because that's all the line of code that we have in the script that we created, and this is your basic script essentially. And so if you, let's say for example this was a perfect running program, and I don't know, probably did more than hello world, maybe it backs up the entire network or something like that. It's great. It just runs on your Unix command prompt, and admins and users can come into the terminal interface and run it. And then a long time ago, people decided, well, what about people from outside, remote users who want to use this file, this .pl file that we wrote? And that's where CGI comes into place. So if you install a CGI interface to it, then you open up that port and you make it available. And it's usually 8080 or something. You make it available to the world, and so anyone can come in and run hello world.pl if you wanted to. So the second part of the assignment, step number 2, is to make hello.cgi, which is a version of this Perl script, hello world, but made for the CGI interface. So the activity is essentially make a new file, call it hello.cgi, and then we're going to change the lines of code here. Instead, now we're putting up some instructions here that says this is a Perl script, and this is pretty classic. This is very normal, pretty classic first line of any script. So when you open up text files and you look at them in editors and VI or whatever it is you're using, and you see this hash sign and the exclamation point, when you see the hash sign, at least hey, this is telling whoever is going to run this thing, which is going to be your Ubuntu kernel or your Debian kernel or whatever it is, that this is a Perl script, and it looks for the command interpreter at user bin Perl. If you go to this directory, you'll see user bin. Hopefully, you'll see the Perl. If not, it's in a different directory. You have to change this to whatever directory it is installed on your computer. In fact, I believe this is what works for the MacBook, but don't quote me on that. Actually, we'd have to go and use a file manager and go in there and see, actually. But then we have, looks like Perl code, and it is Perl code. But what's the Perl code doing? Well, it's taking and it's creating HTML code, because everything that goes through the HTML, public HTML interface, HTTP protocol, is delivered in the form of HTML. Everybody knows HTML is a hypertext markup language for the internet. And so we're printing out HTML code, which is interesting. Because the concept is we're going to the server, going through this little gateway. I'll talk about the gateway later. We're running this file as if we were running it on the local Unix box. And when we run it, when we're going to get the output, we don't have a terminal window where it's going to say hello world on it. Instead, it's going to push the stuff through the HTTP protocol, and set it out through the same gateway we entered into and deliver this to us in our web browser. And when it delivers to us to our web browser is going to parse this code, which is HTML. And it's going to say, oh, print this to the screen, hello world, ends up in your web browser. So it's a really cool test, actually, to experiment with it, to see how the same script, just changing the print statements so that it takes into consideration HTML code and prints out HTML code. This would actually work without the HTML code because all we're doing is printing hello world to the screen. Anyone knows, you bring up Notepad, write hello world in there, call it my fabulous website.html, double click on it and it'll open up and show hello world in Firefox or whatever, you know. It's like the poor man's website or whatever, you know. So it doesn't really do anything, but you know, you don't have to have any code on here that says it's a header or anything like that, you know, just put text in there. So that's what people do, actually. And then people were writing C++ code, because think of the concept. What you're doing is you're just running a Perl script, and the Perl script is in a CGI bin directory that is on the server. So this can be an exe file, it could be another script, it could be a Python script, a PHP script, it could be anything. And believe it or not, the differences between Perl and PHP kind of thin, actually. Except for Perl works through CGI, and CGI, let me talk about CGI for a few minutes, a little slight tangent here. CGI is poor man's website, poor man's scripting language. It's from the very, very original, you know, when people decided, oh, the internet, oh. You know, who thought that consumers were going to have computers that connected to the internet? I mean, who used the internet? Education, the government, you know. We had command line browsers and stuff. Nobody thought about consumers, right? So CGI came around as a short-term solution to that. And we had the Apache server set up already. That's one of the core concepts of Unix to begin with. That was already there, and we already had that set up. So we added this port, this gateway, and the gateway was just a door. It just allowed people from the outside, from the public who we don't know, who wants to connect, to share information that's on our server. And as imagine if you just had a door you opened up in your house, anyone who wanted to, and you gave the key out to everybody. Anyone who wanted to can go in there. That's the problem with CGI. There's no security features on this. There's no cameras. There's no monitor to see who's walking in, who's walking out at all nights, and day and night. So there's a lack of security with CGI. It's just a door. You got the key. You open it up. There's a lack of tool support. You walk in the door. What do? You steal something? I don't know. Sit down, watch TV. I mean, what are you gonna do when you're in this person's house? You got to know what you're looking for. So you got to go find what you're looking for. Same thing with files. What you do in the house happens in the house. You turn the TV on, it happens in the house. So you go through the CGI port and you turn the TV on, it happens on the server. It's happening, everything is happening on the server. Only the output is going to the user. So there's a lot of processes that are created. Each user who walks through the CGI port, sits down and watches television or does whatever on the server, is taking up their own resources, using electricity, whatever. They're occupying a process. They are taking up a lot of resources, and every user takes up its own set of resources, and every user's in isolation out there on the server doing whatever it is they want to do. Not very efficient for the server, because the server is bogged down with user requests. If a server executes a file for a user, it opens up a process, runs the file, runs the executable file. That ends up being, you know, part of, that ends up being essentially a program that runs, right? So we have, every user's got their own program running, and we have resources for each one of those files, and we have concurrency issues. How do the users exchange information back and forth between them? They can't. They're all in their own process. It's just like running programs. So then better technologies came around. And so I'm going to explain sort of the difference between PHP and Perl, because those languages are kind of interesting. And why PHP is kind of taken over for web development, because no one uses CGI. Well, I shouldn't say that. Legacy programs still use CGI and CGI bin directories, because if you've got a C++ program that's written out there, you're going to rewrite it. No, you're just going to leave it working. If it's working just fine and it's not broken, you're going to leave it out there. So Perl is a good scripting language for Unix because it integrates with what they call modules. And these modules provide functionality. Perl is almost as rich of a language as C or C++. There's a lot of programming capability with it. It's not a compiled language, it's a scripting language, and I'll go through an entire lecture on Perl in a few minutes, but it allows you to do a lot of Unix functionality and program writing. So it still has a place in the market because Unix people still use it, and there's a lot of Perl scripts. There's still current Perl support for it. PHP, on the other hand, is a glue language. It allows you to glue pieces together. So you can take HTML code, mix it in with PHP, go to the server and run a Perl script. You know, it's hybrid. It doesn't really run in the web browser. It's pre-processed. But it runs just like Perl. So we have a Perl interpreter on the server. We go through a CGI port to go into it, to access it. PHP, they say, oh, forget about CGI. Let's just install it in the Apache server. So now when you download and install Apache, you'll see, do you want PHP with that? Do you want this with that? Do you want that with that? Because it's all integrated in. And if you're taking the Java EE course, you know, now you've got servlet technology, so we got Java integrated in as well if you wanted to do that route as well. And it all works together, which is really nice. Because who programs in just one language? Nobody does. So if you want to share a component to mix and match between different applications and glue pieces together, you use PHP as a concept because you got more security. There's no CGI. Eliminate CGI. There's no problem with CGI ports anymore. Runs directly in Apache, mixes in with other languages, and it's still a server-side scripting language. Perl is a server-side scripting language as well, which means the script runs on the server, sends the data, sends the output back to the user. It does not run on the user's computer. This is in contrast with other scripting languages like JavaScript. JavaScript is a client-side scripting language. It runs on the client's computer, runs on everybody's computer. Nothing happens on the server. So you can have a real lightweight server, have JavaScript running on clients, and all the processing's happening on the client. And obviously you can see you can't like log into a database like that. You know, you're gonna give every one of your clients your login name and password. I don't think so. Instead, you're gonna embed it in a PHP script, put it on the server. User never sees it. They can't look at the source code of the file that they're running or anything. It's all on the server. It's all protected. So there's mixes and the pros and cons. If you take a web development course, usually they go through all the differences between all the scripting languages. But because I'm talking about Perl today, I need to kind of, you know, compare it with something else at least. So what you're doing here is the old-fashioned way, but it's still a good way. It teaches you about Unix. So you're going to essentially run the, so now you have a command prompt here. You can run perl.hello.cgi, which is going to create HTML output for the same script that just printed hello world to the screen. So everything's okay. Next time what you're going to do now is going to run it through. You're going to run it through the CGI port. There's step number 3. If you follow through, I'm not going to go through all of it. This is going to go through instructions on how to change the mod to the file to make it executable and yada yada. How to run the Perl interpreter in different modes so it does air checking or doesn't do air checking or logging and stuff like that. But eventually, in step number 3, you're going to run it through a web browser. And in doing that, you're going to create an hello form. You're going to run the form, and the form actually gets run on the client's computer. So we have an HTML form-ish that calls a Perl script that's on the server, runs the server script, sends the output in HTML back to the client, and displays it into the form. So it integrates and gives you the whole big picture. That's the purpose of the first project. And I'm not going to know if you did this or not. I mean, how am I going to know? If you set all this stuff up and you ran it and you actually saw it happen correctly? I have no idea. So it's up to you to, if you're interested in it, to experiment with it and do it. Otherwise, when you turn it in, just give me the pieces. You know, because the next question is, well, how do you know if I did it? How do I get credit for this assignment? Give me all the pieces. You know, give me the hello.pl file and the CGI file and stuff like that. And then I know you actually did it, hopefully. So, all right. This is the lecture I really wanted to start today. But you know, it's nice to go over some of the assignments occasionally as well. So that was assignment number 1. Here's your official introduction to Perl. And So this is going to start with the basics, and then I'm going to eventually go through what I just kind of talked about a few minutes ago. Then I'm going to take it a little step further, go through the whole thing. Perl stands for Practical Extraction and Reporting Language, and you're like, well, this is in Linux class. Why are you talking about Perl? It's a core. In fact, if you were here for the last meeting, you learned that Linux has a bunch of tools, and it's all open source, and it all comes from all different directions. Last time we talked about kernels and user modes and basic Unix commands to find stuff, to concatenate stuff, translate stuff, and VI editors and nano, and all the tools that are built in. Now we start looking at, well, how are we going to use Linux and make it functional? And so Perl, 1986, Larry Wall, very portable, very friendly to operating systems, integrates quite well. It's used as a way of, if you're in a command line prompt environment, even if you're in a Windows environment actually. In fact, there's a Perl module for GUI, so you can actually create GUI programs, to run in Windows, actually, or on the Mac actually, in Perl, which is really nice. I'll talk about the modules in a few minutes. So it's gained a wide distribution. It's readily available. There's some seats over here. You want to island over there. Programs syntax are taken from shell scripts, awk, and C programs. So if you take a bunch of C programmers who really love Linux, and you introduce them, and what we're going to do after, probably not until after lunch, talk about Unix scripting and shell scripts, which is the focus of this weekend's lectures. If you give them all the shell script stuff and awk and all the command tools, they still need more. They need more because how are you going to write a program or utilities and things? So tons of utilities and programs dating back from the early 80s written in Perl, or actually from 86 or so. But in fact, I think, yeah, the date is right. It seems like it was longer ago, but it's about the 90s now. At least that was 10 years ago, or more than 10 years ago. But they're written in Perl because Perl gives you more capabilities. Not as bad as C. Well, I should say bad. Not as complicated. So C is an interesting language in comparison. Most of you are familiar as computer science students. You're familiar with C. If you're not, you should be. Compiled language. You compile it once. Is it portable? No. When you compile it on your Unix box, does it work on your Windows box? No. Does it even work on... Actually, it doesn't even work on different breeds of Linux. If you compile on Ubuntu and you take it over to Debian, it's usually compatible, but not guaranteed that it's actually going to work the same way. So then, as different breeds of Unix were put out there, obviously you can probably see portability. So you might think that Perl is actually sort of the start of portable languages, if you think about it, because you can write one script and it's not compiled. It runs in the interpreter and the version of the interpreter that's on the computer that's running it. You send that script to 5 different platforms that are all supposed to be compatible, that are all Unix, but they're different breeds of Unix, different breeds of Linux. It all works because it's not statically, it's dynamically run. And so the static compilation issues and the, creates portability, which is kind of the same thing Java did. Think of the concept. Java, the JVM, is just an operating system running on top of an operating system. So Java's route is, you're taking, make all, if you want portability in a programming language and it's going to be partly compiled, it's sort of a hybrid language, Java, then you load an operating system on everything on top of the existing operating system, and then now all the class files run consistently because they're all running on the same operating system. So their way of portability is to make it all the same. So it's kind of like the exact opposite thinking with Perl in the beginning was, let's just not make it machine specific or compiler version specific. So if I write a script, it's in text. When it runs, it's always dynamic. It's interpreted in the real time. It's running on whatever interpreter is installed that understands Perl. We can update the interpreter without rewriting the program. We can write the program once and use it on all these different computers and breeds. Hence why Perl is very popular. And it has the features of a regular day programming language. It has very functional features above and beyond scripting languages. And, borderlines on being very C capable. So you've got the best of both worlds. So Perl essentially, in fact, you can load C modules and actually run C code in Perl if you wanted to. So it makes C portable. Think about it. So that was a long time. I mean, that was around a long time before Java was around. So Java did not reinvent the wheel in terms of portable languages. So syntax, a bunch of commands, statements, declarations. There's no main. It's not function oriented. It is imperative. It does go line by line. So sequentially from the top to the bottom of the program. It's very C-like, you know, but it's not. It's a totally different language. Each statement ends with a semicolon. That's kind of a C-like thing. I showed this to you in the first example. This is the W is for warnings. You put this at the beginning of your program, and that's how your operating system knows it's Perl. In fact, you do this for, if you have ever written PHP, you put the symbol here for, I think it's an arrow and a question mark, and you put PHP up there. It's a tag that says, hey, this is a PHP script. So, and you'll see in shell scripts, you can put, you know, C shell at the top of it and go, this is a C shell script. So what you get is dynamic sort of interpretation, and the interpretation is going to read the file, whether, you know, if it's an executable file, you just type the name of the file, opens it up, reads the first line, and says, hey, what is this? Oh, it's Python. Okay, Python, and you put a little tag. So this is very typical of all scripting languages. There's a header at the top of the file, tells you what type of program it is. Like in set and awk, Perl completely parses and compiles the program into an internal format before executing any of it, which is kind of interesting. It runs it, compiles it. Well, I don't know if it really, you really want to call it a compilation stage, but it does compile, gathers information, runs the program, and then it executes it. PHP, on the other hand, is a preprocessed, which runs kind of the same kind of concept. PHP, when you load a script in, the PHP interpreter will compile it, put everything together, then execute it. The difference between the two is it delays some of the processing. Like in Perl, as an example, the whole entire thing is compiled ahead of time. In PHP, some stuff is pre-processed, some is delivered, some is waiting. It's more glue-like in terms of a language versus a program. It's sort of like running glue. And when I say glue, I mean running pieces of programs and short commands that are executing in real time and doing stuff that's merging in with HTML, merging in with other stuff. Perl's not designed really to do that. Perl is more like running a C++ program. It's running an executable file, essentially. It runs in kind of the same fashion. So unlike set and awk, Perl executes sequences of statements exactly once. It doesn't go back in and do things over and over again, sort of like a, what do you call it, a daemon or something, or sort of like a, you know, it runs a program once. It's very C-like in terms of the execution mode. Some features. So it has a rich collection of built-in operators and functions, regular expression capabilities, and we talked about regular expressions in towards the end of the last meeting. And it supports Unix commands, it supports regular expressions, it supports a lot of the utilities that Unix people, admins, were very familiar with. No arbitrary limits on array sizes, lengths of contents of strings. If you remember from C days, you know, arrays are statically allocated, it doesn't grow, you know. So it kind of like took some C features and improved them a little bit. C obviously came first, so and then it's because C is statically allocated. You know, you can't change the size of an array, but hey, take the same concept, implement it with Perl, and make it dynamically allocated, and now you can change the size. So no arbitrary limit, and it doesn't use memory the same way either, so it's nice. Comes with a symbolic debugger. So in terms of memory, because I mentioned it, the memory that you're running in is in the interpreter, and the interpreter is managing the memory for Perl, which is kind of the same concept of most scripting languages. Python, PHP, they're all running the same way. The interpreter, which is kind of like the same thing as the JVM, the Java Virtual Machine, manages the memory for Java, does garbage collection, does all sorts of things. Also does the Perl interpreter. It can have security in there. You know, don't touch this file, don't touch that file. You can't open files, you can't write to files or change things. You can set certain parameters for certain warnings and no warnings, and output goes here, redirect the output or something. you get more control over the execution environment. It's not running on the open Unix system, it's running inside of an interpreter, which is protecting it sort of, which gives it some bonuses. At first, used as pattern scanning and report generating language. So we go back to when we say practical extraction and report language. That's why it's called a reporting language. It started out with good intentions of being a practical extraction and reporting language. And then it turned into a programming language. It's kind of like how JavaScript kind of turned into a programming language. It really wasn't, actually. It was to make some dynamic behavior on a website. Now people write functions. In fact, you can actually write object-oriented style programs in JavaScript. Treat things like objects and run methods on them. And I was like, whoa, it never started out that way. It's just kind of the same thing what happened with Perl. It never really started out being a full programming language. Instead, you ran, if you think about internet development, what do you do with a search engine? In fact, Google uses a lot of Python, which is a very similar language. And Python has special structures in there for sorting lists, for concatenating lists, for finding things in lists, for gathering lists, making lists. What are lists? Search results. So if you think about the concept of writing an algorithm to perform a search using a web browser, aka searching on the internet. So you can actually write a nice little Perl script to go out there and create a bot out of it, actually. Go out there and search around and find stuff and get logged in here, logged in there, and all over the place. Because it goes out and it reports. There's reporting features. In terms of reporting, it's sorting data. It's very data. A lot of features associated with data processing, list processing, and structures in the language to support the scanning and reporting, essentially. That's how it started out. Now it's used for system administration, client-server programming, CGI programming, database access, and other miscellaneous tasks. Many modules that are available. And you may have heard of some of these modules, perhaps. It's a very, the modules make Perl into a glue language. And the modules actually are more supported in Perl than they are in any other language out there. So here's a Perl example. So this is a kind of a, it's like a upgrade from Hello World. And you're not going to be able to learn Perl scripting and Perl syntax all in this one lecture. This is supposed to get you armed and dangerous to go out and kind of experiment with it on your own, which is the purpose of that first project. But it prints something to the screen. It says, what's your favorite color? And this is a variable here. It says that color is equal to standard input. What does that look like? It looks like C++, or actually C, I should say. If you remember the first interactive weekend session, I talked about standard input, standard output, and standard error, and redirection of output and stuff. Well, this is just redirecting the input, putting it into a variable called color. It's doing a chomp on color. What's a chomp? It's sort of like a switch. All right, it's getting the information out of color. I'll talk about chomp in a few minutes. Not really. That's kind of a misleading statement. It's not really like a switch. It's. I'll talk about that in a few minutes to give you a fair definition of that. Color is equal to blue. Kind of not very programming-like, but we can actually use an equal sign if we don't want to use the characters. So it's flexible in terms of its syntax. Blue, it's pretty standard. Single quotes instead of doubles. Print, this is my favorite. Else, if it's black, print. I don't like that color. I do like this color for my shoes, black shoes. Okay. So running in a Unix environment, if we were to take this, in fact, you can take this if you're on a MacBook right now. Cut it out of the lecture slide and put it in a text file, and then run through. And, well, if you got Perl, you go Perl space the name of the file you just created. Otherwise, make the file executable and just type the name of the file and it'll run the script for you. In fact, it depends on how much time I take at lunch, but if I do that, I can probably do it and show you myself on this MacBook, actually. You can see how easy it is to write a script, actually. So in terms of running it, you can explicitly invoke it from a program. You can say Perl options, this program, my program, arguments that might exist. You can use the declarative inside of the program, declare arguments inside of it, debug mode with a D, interactive mode, using an O and a DE for debug mode. And you'll see it's actually kind of flexible in terms of how it runs. And it can actually be called from other programs. In fact, you can take and sometimes embed Perl inside of other languages and say, run this little script here and do this, which is nice for, in terms of gluing. The other thing that Perl does actually that I should mention before, because I talked about, briefly mentioned the concept of variables. In the first interactive session, we looked at environment variables, print environment, and the concept of being able to set variables. And the concept being inside of a Perl script, you can call and use those environment variables as if they were declared and defined inside of the program. So they become, the entire Unix environment becomes part of your program. So you don't have to like redefine the wheel. If you already have home out there, you can use home. You can say, $home. And it's going to be the path of the user's home directory that was set in the environment variable. So a lot of Perl scripts are using environment variables, setting environment variables, running utilities that are in Unix, and performing all sorts of different activities. It's a lot easier to do it that way than it would be to write a C program. So, there's ways of getting Unix. In Unix, there's ways of getting environment variables inside of your C program. But it's a lot more work than just using the environment variable. It's already given to you. So this one makes it a little bit easier, which is why people like this language. Data structures. 3 different types of data structures: scalars, arrays, and associative arrays known as hashes. Mentioned before, what is Perl good for? Extraction, reporting, in terms of why it was originally created. So in terms of working with lists and data processing, this is its strength right here. It is extreme strength, is the ability to work with all sorts of different types of arrays dynamically. So arrays are indexed by numbers starting with 0. Hashes are indexed by strings. So here's some examples here where we have scalars, where we have this variable $str. The world is round. It's a string variable. So there's no initialization. There's no declaration. There's just an initialization and a declaration all in one statement. So it's not as structured as C. You don't have to say, integer I is equal to such and such. And then if you use I further down the road as a string instead of an integer, the compiler comes back and complains too. So I could say $string is equal to 1, and now it's a 1. Now I can say it's a string. Now it's a this, now it's a that. Which actually PHP does the same thing. You can it's not a strongly typed language, which means you can mix and match data types with variables. You don't have to declare the variables. You don't have to declare types on the variables. There's no type declaration here. And this guy here and this guy here look pretty much the same, don't they? All they have is a $sign. So remember, if you ever see a $sign in front of anything, it's a variable. So any type of variable you want, a float, a double, an integer, or a string. So this is a number. Arrays are a little bit different. In fact, arrays are kind of interesting. And the @ symbol gives you the array. I don't really associate an @ with an array, but I always think of this in terms of a URL, @ something. But actually, believe it or not, the meaning is very similar. Because if you think of the concept of the URL, say bhacker @ itu.edu, well, there could be a bhacker @ Gmail, and there is, .com. There could be a bhacker @ CSUE, there is. Because it's bhacker @ it's like all the same bhacker, but she's at like different addresses. Well, kind of similar in concept. @ students, meaning we could have an array of students that would equal this, 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 and this, and this, and this, and this, but it puts it all together instead of separating out each individually. But you can get at each one of them individually here, and we can get at the structure and it's basically, think of it more like a pointer to a location, to a, to a grouping or something of that nature, if that makes any sense. But @ students here is going to equal to Mike, Lisa, and John. Print, and then this is the interesting thing here. So we said create students as an array, but when we use it, we're using this $sign here. It's going to say, $students, which is we're not using it as an array anymore. Now we're using it as a single value. We're saying 0, index value 0, just like C++. So if you don't like arrays in C++, you don't like them in Perl either. They all start with 0 and they go 0, 1, 2, 3. So this prints out Mike. This prints out Julie, number 3, 0, 1, 2. I don't know where Julie is in here. Add a new one, I'm sorry. We're adding a new element here. We're going to say, you can't do this in C++ though, or C. Because if you create an array of Mike, Lisa, and John, you have an array of 3 items. You can't put, starting with 0, so you can't put the 4th item in here, which is Julie. So as I mentioned before, you know, Perl is dynamic, so arrays don't have any bounds to them. And then you can clear out the whole array by just saying an empty array. This array is going to be equal to nothing, which means you've gotten rid of everything that's inside of the array. So what if, you know, for example, you did a search on the internet and you came back with 1,500 results, and then you did another search and came back with 5 results. In terms of memory storage and allocation, arrays in Perl are a lot easier because you don't have to go, well, how many results do you think you might get? 2 million? So you declare array size, my results is equal to, you know, and I don't think they actually can do a 2 million sized array. I think the compiler has limitations on that, so. Although it might work, memory may not necessarily be available. Perl data structures, continuing on with the concept of hashes, and the hashes really don't exist very much in most languages in terms of a built-in data structure. This is usually something you have to create on your own, and it is in C++ and C. There's no data type called a hash unless you create it or use one of the standard templates. And now we see this percent sign instead of the dollar sign. It says it's a hash. So the @ symbol for arrays, the dollar sign for variables, the percent sign that says, oh, this is a hash. And what's a hash? Well, hash is going to be Julie, President, Mary, VIP. Think of it more like a dictionary or a lookup table. Hash is basically a key and a name associated with an item. So Julie's the president and Mary is the vice president. So we can print out, we can ask who Julie is, and we can come back with president. PHP supports hashes. Other scripting languages support hashes. Creates a dictionary kind of structure. In fact, some languages actually call them a dictionary instead of a hash. But it's a lookup table. You put keys and with values associated with them. So if you go print, and then now we're using this dollar sign again because we're treating it like a variable, Julie, it's going to print president because we said print this name and gives us the value that's associated with the name. And if we said print employee Julie, we could say, you know, employee, or, you know, print employee Julie. We could say, you know, print John. John is the controller. He's not in here, but, you know. Or we can also use the same thing, equals 0, to empty it out completely, which is the same thing we do with the arrays. Are we running out of chairs? We got one left right here in front. They stuck me in a small room. Hopefully we won't have any more. If we do have any more students, we're going to have to bring in more chairs, and then we'll have to move. I have to break. So we're good for now, but if we get any more, we're stuck. So. Scalars, strings and numbers. So we actually kind of looked at this already in terms of the hello world. We saw scalar. Actually, we saw them already in a couple of different examples. So Perl supports the strings and the numbers as the simplest kind of data. And we don't really care about what kind of number, whether it has what the precision of the number is. A scalar is either a number or a string or a character. And a scalar value can be acted upon with operators, like a plus operator or concatenation yielding a scalar results. So we can say a string and add it to a number, and we get a string with a number on the end of it. We can take two numbers and add them together and get the results. So, in terms of the documentation for it, the MIT has really nice documentation on Perl. In fact, there's a lot of development, a lot of research. It's one of these research languages from the past that turned up being a really nice contribution to open source, a nice contribution to the Linux Unix community. And you can use that chair right there too, the executive chair. We'll have to fix this problem at the first break. So it works like, you know, it works, the reference itself, if you go out and just search Perl data structures, MIT, you'll find a lot of information on the research and the kind of the makings of every component in Perl in terms of its research and all the different versions and all the different current activity that's actually out there as well. In fact, there is still Perl development going on because Perl modules are very popular. There's a Perl module for practically every utility out there. And I'll be talking about modules a little bit later. So it works like the English word the, going back to the concept of the scalar. So simple scalar values of days. So the days is 28. The 29th element of the array at days, which we saw in the previous example, this would actually yield the 29th element. We could say February, which is the February value of the hash, with the with the % days. So, and we saw this in the previous examples here in terms of when we printed something out, we used the scalar, which differentiates itself from other structures. So it's very symbol-oriented, if you think about it. All of the syntax for all of the variables and the variable types, instead of using a defined type, we're using a symbol instead of a type. So instead of saying, this is an array, we use the @ symbol. So this is a scalar, we use the $. It tells the interpreter what it is we're looking at. And down here on the bottom, we have the $sign here, the hash, or the number symbol, and the number symbol, and the last index of the array at days, which is, so we can say, days, give me the last one, or give me the, give me something out of that. So very symbol-oriented is the point of these examples. And oh yeah, here's actually, I should have put this on the previous slide, but here's the URL. It's actually, last time I checked it, it worked. So if you wanted a full documentation, maybe there's a lot of Perl books, PDF files on Perl as well, because I'm only giving them, you can't learn an entire programming language by one lecture, and I'm only going to give you some examples that basically express how Perl is different from other languages. So the entire array and the array slices are denoted by the @ symbols we've seen, which works like these or those. So it's very English-like. I can say the days, so scalars use the arrays are these or those because you have more than one. So those, these. So in terms of the English syntax for it. So these days, those days, similar to the, at days 3, 4, 5, 6. So at days. And that's the other interesting thing about the arrays themselves. They can take numbers, they can take characters, they can take scalars. You can actually nest items in array elements as well. Entire hashes are denoted by the % as we've seen in the previous example. So key value, key value, key value. So key value 1, key value 2, key value 3. It's all essentially, the hashes are treated just like arrays in terms of the index values, but for each index you have 2 values instead of 1. So, and it takes it in the order in which you put them in. So each variable type has its own namespace. So you can use, with fear of conflict, the same name for scalars, variables, arrays, hashes, subroutines, everything. So each one of the different types has its own namespace. So I can have, if I were talking C, I can say I can have an integer I, and I can have a double I and a float I. But because I have an integer, a double, and a float, the i's are all treated differently, and there's no issue. Well, there is in terms of the logic, because usually we have unique variable names for the programmer, so we can keep track of variables. If everything was I in the language, but we can have an I array, an I hash, an I scalar, if we want. So use it with caution is what I'm saying, because although you can have it, don't necessarily want it. Why would you want that? Because then you can write a generic script that if you only had one item, let's say going back to that search results kind of example, it came back with, 2,000 results or 500 results or 1. Or maybe the results were key pattern sets. You can have one variable name that you're using for everything, all the different types that you might have come back, and then when you write your rest part of the script, you're using my results. Let's just call it my results as the name. And you can embed my results into everything. It's kind of like creating a global variable for pi, and everywhere you use pi, the definition of pi comes out from the original setting of it. But the definition of pi in this particular example might change into an array or to a hash or to a scalar depending upon how you defined it. So you don't know necessarily. So it gives you flexibility. In this context, the $foo and @foo are different variables, which is interesting. So the context is a scalar and a list. Certain operations return list values in contexts wanting a list and a scalar otherwise. So the context in terms of what you're getting is going to be a scalar or a list. So we have operators for numbers. So these are the standard old operators. Addition, subtraction, multiplication, division. For example, range, dot operator. Specify a range of integers. So print 1.9. That's a little different than C. You can't do that. Let's see. So we have the range as the dots, which is going to print out 1, 2, 3, 4, 5, 6, 7, 8, 9. So there's a lot of interesting things in the language that make some improvements in terms of on-the-fly scripting. So operators on strings. We're going to have concatenation, which is the dot. So an example, hello.world is going to give us hello world. Or we can repeat. This is a nice one. We don't have this one in C. We can do concatenation in C or C++ easily. You can just use a string class and come up with all sorts of methods for stuff. But the string repeater operator, so we can say string x number makes as many concatenation copies of the string as indicated by number. So if I said Fred times 3, and this is the times operator. So it's a natural kind of times, but it's concatenation with times. So it would go Fred, Fred, Fred for 3 Freds. Concatenates it 3 times, puts it in a row. That's pretty nifty, I think, actually. Here's a little summary of some of the other ones. And as I saw in the beginning, in the Hello World Perl program I showed you from project number 1 in the beginning, there's a string associated with the numeric expression. So in here we have equals, not equals, NE. So the language, again, going back to kind of trying to be user-friendly towards English kind of people. In terms of the comparison, the equals, we could use the double equal style, or we could use equal. So, and you can kind of go through the rest and, kind of see how you can be flexible in terms of the way you're naming it, using it. Most programmers who are like hardcore C people are going to use the equals. Most people who are, they want to be more, less programming-like and more human-like, put equals in their EQ, just to mess people up when they look at the script. So, I don't know. Scalar variables. So scalar variables are like those of the shell. I haven't talked about shell variables yet, but they're the same concept. In fact, the variable holds a single scalar value. Variables can be assigned to any type of scalar value, and Perl keeps track of the type for you. It does dynamic typing, as I mentioned before. So you can create my variable. My variable at one instance can hold a number. Another one, it can hold a string. We only have numbers and strings. We don't really have anything else. But well, in terms of scalars, it can actually change and anything it wants to change to. The $sign is always used to denote the variable and also expand the value of the variable. So here's some examples. So see the Perl from MIT. Well, actually, there's more examples in that documentation. If you go online, look at the MIT manual. But if I go, here, to find a scalar available variable, it's going to be equal to value. This is an assignment operator that equals the assignment. Same thing as C, C++. So if I said print this one, same syntax as C or C++. So it gives you the, slash in the end. And then I can say, car is equal to this one here, print out the variable, prints the value of the variable. So with a line return at the end of it. The car is going to be equal to Buick. The count is going to be equal to 1. So if you can, just by glancing at this assignment, you can see that there's no type associated with any of the thing. So it's typeless. So not required to declare or initialize. You can just say, hey, variable, where'd you come from? Okay. So pattern matching also exists. In terms of pattern matching, if a variable equals some pattern, So it's kind of like using it like a string, but the variable might actually have some stuff in it, numbers and strings and stuff. Or if it doesn't equal something. Substitutions as well. So we can say, variable 1 equals this pattern, replace with that pattern. So take this file that has all these comma delimited fields in it from this export that we've got. Because remember, we're reporting and we're extracting. So we're extracting data out of a database as an example. And let's say the database exported the file with comma delimiters. And we don't want commas. Our program is meant to read spaces or tabs or something. We just replace it, all the commas with tabs or something. And you can write a simple little utility that does that, fixes your file up just fine. Person who didn't know Perl would open up that file of 2 million records and be taking out all of the commas. That's like the bad way of doing something. So, functions on scalar variables. And here's where we're going to go into Chomp, which is going to, and Chop and Chomp, and I kind of explain those because I kind of led you astray on the first time I mentioned it. Chop. Chop takes a single argument, a scalar variable, and removes the last character from the string value of that variable. So it chops off the last character. So at doc is going to be the Perl document. Chomp doc. Doc is now the Perl document. Oh, where'd my T go? So instead of creating a for loop like you would do in C or C++ to remove off the front, to remove off the back, to process some list or some thing, you can use Chomp to go through and take off character by character. Or Chomp, which removes only the new line character at the end, if there is one. If there isn't one, it doesn't come back with an error. It just says, okay, I'm done. Removed it. It wasn't there. I didn't have to do anything. Still gets paid, but he didn't have to do anything. So let's say, and then you get this because when you take in cin, or oh my god, that's like so totally C++, cin. If you use standard input from a terminal, you're going to get, and if you take terminal information or internet information, you're going to get line returns, you're going to get tab spaces, you're going to get all sorts of different things you don't want. So Chomp easily removes the line returns. And if there's no line return, nothing happens. It just comes back and says, oh, okay. And here's your standard input that gives you those line returns, which is sort of the issue. So when standard input is used where the scalar value is expected, Perl reads the next complete text line from the standard input up to the first new line, and then uses the string as the value of the standard input. So at A is going to be the standard input, get the text. Chomp A, get rid of that pesky new line return that's at the end of it, which is the same as Chomp A equals standard input. So you can embed the initialization of the scalar inside of Chomp. And Chomp's a function, just like Chop is a function. These are function calls, very similar to C, C++. But they're built-in functions. You can also create your own functions, just like C or C++. In terms of the arrays, here's some operations that you can perform on the arrays. By concept, it's an ordered scalar data. So an array is a variable that holds that list. So arrays are dynamically allocated, as we've seen already. And they're denoted by the @ symbol, as we've seen already. So here's just to review the concept. We have @ arrays 1, 2, 3, 4, 5. In terms of the assignment, we can say Fred is the array name. 1, 2, 3. He's 1, 2, 3. Barney equals Fred. Copies Fred to Barney. So it takes and copies the whole thing. Instead of, in fact, you can copy arrays in a similar fashion in other languages. If an array variable is assigned to a scalar variable and the number assigned is the length of the array, we could say that the number of elements, we could say length is equal to, and give it the entire array. So if the array variable is assigned to a scalar variable, the number assigned is the length. So this will give you automatically the length. By using it assigns, no, this is the minus sign. Why is the minus sign in there? I don't know. It's just for the example. It yields that to you. There's no minus sign in there. It's type. I was going to see if the typo was going to continue. I believe that was supposed to be a bullet or something, and it was an indented. Looks like an indented bullet, but these guys didn't have it, which is kind of weird. I need to edit that. There's no minus sign. You're basically assigning the array to a scalar and it actually gets you the length instead. It just says 3, something that comes out of it. Access the single element with the index number in the brackets. We've seen this already, noting that the @ on the array name becomes the scalar on the element reference. So we say print array 0 prints out the first element of array, which is 1. So array 0 is 1, 2, 3 in there. So, yeah, that is the bullet. Yeah. Huh. No minus sign there. It's a bullet. So we have an undefined, which is returned when accessing an array element beyond the end of the current array. So instead of getting a strange memory addressing error or some odd behavior that's unpredictable in C or C++, we get undefined. So in fact, I think, other languages actually kind of do come out with a little better error checking than C. So that's really not a good comparison. Using the hash number here, the array is used to get the index of the last element of the @ array name. So it just returns the last, and then we can return the last, and we can return the last recursively. In fact, looping is really easy. Same if-else statements. It's the same concept as C, actually. Which is why this was basically designed for C programmers from old Unix days to do scripting above and beyond shell scripts. So it actually incorporates a lot about the C language, but improves a few things. We can do a stack, actually, pop and a push on functions. So when arrays are used as a stack of information, then the new values are added and removed from the right-hand side of the list, which is a classic stack from data structures. So we can push onto my list the new value, like. We can, or it might be like, actually. We can push on, or we can take my array, and it could be equal to the new value. We can say old value is equal to pop, which is going to remove the last element of that particular list. So pushing and popping just like stack elements, essentially, that are built in on arrays. So essentially what you've done is you've created an instant stack or an instant queue, depending upon how you're using the structure from an array. So kind of creates a more dynamic data structure programming environment. That would be nice, actually, if C or C++ had that. Just take an array. It's easy to add to the language, actually. Probably come up with your own functionality for it. Write your own algorithm for that. That just basically takes an array and pops and pushes. But there's too much sorting and reorganization in an array, in C or C++. There's less sorting and stuff like that. If you wanted to pull elements off of an array, you've got to use a for loop in C or C++. In fact, a lot of people don't, in fact, it's a lot of work. Let's see. to use a for loop for that. Shift and unshift functions perform similar activities in the pop and the push on the left side of the array. So this is your queue operations. You're shifting it in the queue. Now you're number 1. Now you're next. And you're coming in the back and coming out the front. As an example here, we have add Fred is 5, 6, and 7. Shift it, which would be like shift the item and then print out the item. So x is going to be equal to, and x gets 5 because we've shifted. So, and x is now going to be 6 and 7. Fred is now 6 and 7 once we shift once on it. If we shift Fred, we get 5 coming out of it. We can sort the array automatically. So it returns a sorted list of the ascending ASCII order without changing the original list, which is the key. It doesn't change the original array, it just sorts it for us. Prints it out for us. We have a reverse function as well. It reverses the order of the elements of the array, returning the resulting list. So if the @ list was 1, 2, 3, and that was A, B is going to be equal to the reverse of A, which means that B is now equal to 3, 2, 1 instead of 1, 2, 3. So that's a good example of it because now B is permanent. If we shifted A, or reversed A, or sorted A, actually shift pulls it off and unshift pulls it off. Pop and push pulls the item off, changes the array. The sort and reverse, they don't actually change the structure of the array. They just manipulate the data for us. The sort function returns the sorted list. Actually, that was on the previous slide. So yeah, basically returning the sorted list. Chomp we've seen already. Chomps off the line return at the end. So now the stuff is... in fact, here's an interesting example we hadn't seen yet. If stuff was standard input, standard input, standard input, and we wanted to chomp the entire array, it takes each one of the items and applies the same function to each one of the items. So there's no looping involved with this. So there's no for loop that has to go through each one of them. Chomp the first item, chomp the second item. Filtering a list, because remember this is for extraction and printing, stuff like that, data processing in terms of the language. So the grep function may be used to select from a list. So at toys is equal to QW car, race car, truck, blue car, train, and we use a grep on there to say car from at toys. And so if we print it out, it's going to print out, if we print at cars, car, race car, and blue car are going to be printed out. Hello, how are you? Long time no see. Yeah. Are there chairs left? You might have to bring your own. It's bring your own chair day. Bring your own desk. I can't believe we filled this room up, actually. At the break, maybe we'll try and find a bigger room. Alright, so the car, race car, blue car, essentially, is going to come out of that. We can grep from any list. So we have at demons is equal to grep demon, and we have the any list at all from out there. We can take it from another list that we have imported in, or use or result set or something like that. Or maybe this is a list of items that maybe came out of another script or something. So iteration through an array, we have the C style for loops that we can do just like we did in other C programs, unless we're going to use the automatic sort and reverse and those functions that we can actually apply to it. With the C style loop, and it gives us kind of the same fashion. In fact, I don't really need to go through this because it's the same concept as C or C++. The for each loop, that's not really like a C or C++ statement. That's more of a, what's that language I'm thinking of? Pascal-ish language. An old language called Pascal that nobody programs in anymore. Came out with a for, they had the begin, the end, for each, which is more of a scripting language, actually. Pascal wasn't a bad language. For each element in the array, print out the elements, which is kind of a better improvement upon the for loop. The standard input is an array. In fact, we do this in C or C++. We take standard input, and it comes into an array from main. We take those command line arguments, and we parse them out. It's automatically an array. This standard input gives us that format. So we've actually done this, if you haven't realized. If you've ever written a C program that used main with inside of the parameter list, you said, get me the command line arguments. In fact, most people just put that in there anyway, and you get the command line arguments every time you run that program, but normally you don't really give it any command line arguments. There's nothing to parse out of that. It's always a blank anyway. But let's say if you ran my program space 1 space 2 space 3 or something, and it's going to take it automatically. So it lists the context, returns all the remaining lines up to the end of the file. Each line is returned by a separate element in the list. So the at symbol A is going to be equal to standard input, reads the standard input into a list context. So it actually creates the list for us automatically, but that's more of a standard input as a concept. This you may have looked familiar to, the arguments, add arguments, which is kind of C-like as well for command line arguments. So argument value, V in the array, taken from C. Array contains the command line arguments. This is how we're getting the command line arguments in actually from standard input. Because whether you realize it or not, standard input's being used on every single command line. Every single command line statement is standard input to something, whether it be a C compiler, an interpreter, a Perl interpreter. So the argument values are going to be the items that are contained in the array that comes in automatically. It doesn't include the program name, obviously. Same. Actually, C++ you can get the program name out of that too, but it's kind of senseless if you think about it. You already know what program you're running when you're running the program, so why do you need the program name? So it doesn't include the program name in Perl. The 0 contains the program name, which is kind of the same concept as C. Actually, it is the same concept. Used in scalar context to determine the argument count. So if at argument doesn't equal 2, you come back and say, hey, you have to put in 2 arguments when you run this program. The first one is the file you want to copy. The next one is the destination, or the name of the file, which is the common kind of file copy error message you see. And you see this keyword die. It's kind of interesting. Perl, you can die in Perl. Die, which means end, exit the program. Usage, for this program, the in-file argument. So it's basically giving you some user input. So in terms of the hashes concept, the hashes, you recall from the previous slides, collection of scalars, which have individual elements selected by some index. So we have a key and a value, a key and a value, a key and a value for index 0, 1, 2, 3 for each one of the items. So the index values are arbitrary scalars called keys. There's no order. It's actually not an ordered list. The hash is unordered, actually. But the items, you search for the item. You say, well, where is, you don't usually go item number 1, item number 2, item number 3. Instead, you ask for the key, and it gives you the value that's associated with the key, which is a little faster lookup, actually, than looking and trying to remember index values. So they're used for to retrieve values from arrays. So the elements of the hash have no special order to them, and the hash is denoted by the % sign, as we've seen in previous lecture. So elements of the hash are referenced like this. We have the curly brackets for the key. It's bring your own chair day. Sorry, I forgot to bring my own chair. So tomorrow we'll have people in beach chairs and no. Actually, that might be fun. She said bring your own chair. Lounge chairs, lazy boys. Chairs with drink carts and stuff. All right, examples. I'm trying to liven it up a little bit. So we have the hash chair. Oh, he did bring his own chair. Look at that. All right. Definitely in another 15-20 minutes when we take a break, we'll switch rooms. Wise decision. Okay, so as an example, the % car color is going to be equal to Buick yellow. My color, car color Buick. So we essentially take car color, have it equal to Buick. My color is now yellow. We can take the hash copy from one to another. Copy is one, original to a copy. So we can make copies of it as well. So more hash examples here using the equals greater than operator. So, and I forget this minus sign is a bullet actually in the slide. I have recently discovered I need to edit this a little bit. So the hash sign car color, and we can say Buick, and this is the assignment operator essentially, which is going to be that equals arrows, yellow, GE is red, Nissan is blue. Do we have GE cars anymore? I don't know. Maybe I think that was Geo, but the Geo Metros. Is it Geo Metro? I don't think we have those anymore.
It's a new one.
Huh? They're little cars. The Geos? GE? GM. Maybe that was supposed to be GM. I don't know. Buick is GM, General Motors. So it says GE, General Electric. Anyway, there's some typos in this lecture. So, key functions. So the keys from a hash name, from the name of a hash table, yields the list of the current keys in the hash. So an example here, keys. Keys is going to be equal to the hash. So gives you the $ once for each excuse me, this is a comment, once for each key of the Fred hash. So for each key, from key of Fred hash, print out at this key we have this value. So it's going to give you from the key, it's going to print out the value. So you ask for the key, you get the value. Long story short. And I can show you the value. In terms of hash keys, and remember in the beginning of this lecture I said, well, one of the beautiful parts about Perl is you can use environment variables directly inside of it. You don't have to like copy stuff in and do stuff like that. So here's special environment stores environment variables. So a hash stores the environment variable. So we have print the environment variable shell. Shell is going to tell us what shell is. Because shell actually knows, because we've already set that in the environment variable that this is shell. So we can go, the environment, in fact, you can do this. In fact, a lot of people do this. Print env is giving you essentially the same kind of functionality in terms of printing env from inside. So it's very similar to shell scripting. So Perl is sort of a hybrid of C and, I should say, shell scripting. C and C++. Oh, another guy. You just brought a regular chair with you today. Huh? I was saying, I was bring your own chair day. That's going to get old after a while. All right, so value function. So value, so this is how you get the keys, essentially. So you know, from a key from a hash returns the value. A printing environment with the name of an environment variable is going to print out the values associated with the environment variable. So the values function yields a list of the current values of the particular hash that you've created in the same order as the keys returned by keys. So if you ask for the keys, it gives you the keys. Ask for the values, you get the values. In the same order. And the order is essentially the way it comes into it, which may not necessarily mean anything. So the last names are Barney, Flintstone. This is the Flintstones. So Barney, Flintstone, Jerry Smith, Jerry the cat. Is it Tom and Jerry? Yeah, Jerry's last name is Smith, I guess. Maybe not. The last name values are going to grab the values associated with Barney, which is going to be Flintstone and Smith. So Flintstone and Smith will be printed out. So the each function as well. So it's very similar to the for each loop, but the each function returns the key value pair as a 2-element list. So used to iterate over an entire hash, examining every one of the elements. And here we have while first name and last name exists equals each one of these last names, and we're going to print out the last name of the first name is last name. So it's kind of a great way of creating loops. So there's a little bit more looping functionality in Perl than there is in C or C++. The delete removes the hash elements, takes the hash reference as an argument. So you delete last name Barney, and now it has only one key value pair now. So we had Jerry and Smith and Barney Flintstone, so now we just have Jerry Smith in there, one person in there. So you can delete easily. And which is very functional, actually, if you think about it, because what you can do is create a script that goes out to the internet, gets thousands and thousands of search results, and says, well, the person made this really broad, and we don't really want results that are associated with, it's bring your own chair day. So, he's like, oh, like he understood me. Wow, okay, that's self-explanatory. So, anyway, so let's say the user created a search result, put too much in there, select star, whatever, Then you could actually narrow it down, go, well, delete everything that has, computer in there. I wasn't talking about computer algorithms, I was talking about another sort of algorithms or something. So, long story short, it allows you to completely delete out certain sections depending upon values that might actually be in the results. It's nice for search engine results and things of that nature, list processing. So checking hash keys or values, so checking for a true-false value. If this is John in there, do we have an employee John? Checks for existing key, so if exists John, checking for existing key and a defined value. Is he defined? Using the syntax, define, exists, or is he there? You might have to actually make a separate row right here, if we could, because we're sort of blocking the entrance now. So undefining a value, we can undefine. So here we have the check to see if he's in here. Does he exist? Let's define a value. Oh, wow, you brought a desk. Undefine a value. Delete a value, so we can use delete here. Deletes a key value pair. And then check if the hash contains anything. If something, yada, yada, yada. So the control structures, as we've seen before, Perl supports the if, the for, the while, very similar to those in C. So assuming you have a C background, I don't have to bore you with the way to iterate through in terms of loops. The for each, as we've seen before, which constructs is from C shell, actually, and we'll look at C shell later on. So for each example, if the list we are iterating over is made out of real variables rather than some of the variables, returning a list of values, then the variables that are being used for iteration is in fact an alias for each one of the variables of the list instead of being merely a copy of the variables. So the for each comes in handy in terms of being able to iterate through and get a copy of it. Or, as an example, here we have the ability to say, at numbers equals this. For each one of the numbers times equals 3. Just like an array would actually change the values that are associated with them. Actually, not really. An array wouldn't. If we passed it to a function and did that, it would. So. But essentially, we would print out now each one of these numbers times 3. So it doesn't take a copy of it. It's actually more of a pass by value, pass by reference sort of thing. Actually passes it by reference instead of making a copy of the variable. Is there somebody out there? Can you just tell them it's a bring your own chair day? Right, next time it's going to be a bring your own computer. Well, it is a bring your own computer day too. Huh? Yeah. Email me a chair. I don't know if I can email you a chair, really.
So that's fun that just bring chairs.
Yeah, on the email next time, it's also bring your own chair day, so bring your own chair. Bring your own lunch, too, I think, too.
Yeah.
Just bring your own everything. Bring your own teacher. I'll stay home. I'll go out and play golf. Bring your own teacher. All right, basic I/O.
You can't get the teacher's same like you.
Oh, thank you. Thank you. All right. Basic I/O. Let's finish this up so we can take a break, actually. Most of us are sitting here going, when is she going to stop? Right. Pretty soon. Okay, basic I/O. Input from the standard input. So Perl uses the $sign to contain, or this symbol here actually, to contain the line read in from the standard input. So as we kind of saw in previous examples, this is the explanation for it. And again, we have the symbol for the scalar A is going to be equal to standard input, reads in the next line, and then we have reads in the lines until Control D is actually entered in, because we're using the @ symbol that says we're going to have more than one item. This says one item, this says more than one item because it's an array. And then typically we might have a while defined, define this thing here, while it is there, take and read in from the standard input, process line by line, while we have items to actually read it in. So when no more lines are read, the standard input returns undefined, so while defined. So it's using the concept of the built-in functions to examine the input to see, well, somebody put something in there. It's like while get character doesn't equal nothing. And then we have the operator here. Operator, like the standard input, gets the data from files or files, more than one file. This is sort of like the directional operator, actually, from the less than or greater than. Do a list. In fact, I did this for you the first weekend of this course when we were doing command line arguments and things, where we said ls something or other, and we use one of these arrows and say send it over here, send it over there, and send it to a file. So here we're using the symbol, using both of them together, and using it for a similar purpose, but we're doing it inside of Perl. So you may also get the impression at this point that Perl incorporates a lot of C shell script and C terminal prompt command lines arguments and command line statements and things. So it operates on the standard input, specifies the command line that invokes the Perl program. This one looks at the argument arrays. So here's a little script that says, while we have arguments, print out those arguments, essentially, which is what it's going to do. It's going to print out the arguments. Output, so standard output prints out the normal output. Printf for formatted output. Printf might look familiar for C programmers. Scanf and printf, you can use those. So it's not C++ like, it's C. So I guess if you really think about it, C was around before Perl, and then C++ came out after Perl. So it's not really incorporating too much C. It's not object-oriented at all in general. So Perl supports the same regular expressions as in sed. I left it sed during the first weekend meeting. So if you remember, or you go back and look at the videos for that. So we have the equal squiggly line, the match operator. So it takes a regular expression operator on the right-hand side and changes the target of the operator to some value. And the target of the operator can be any expression that yields some scalar string value in the end. So if the standard input is going to be equal to a yes or a no, in terms of a lowercase or an uppercase y, then what can I do for you? Do you have a question? Yes. Type one. So if the standard input is equal to one of these items in here, and this is more of a set expression than it is a Perl expression, but it's incorporated in, and incorporates the same kind of syntax. This is a nice one too as well. In fact, we went over split, slice, and I can't remember what else we went over the first weekend. So split function. So split takes a regular expression of a string and looks for occurrences of the regular expression within the string, and it splits it out by the delimiter. So you express, the expression, split it out by spaces or by commas or by something that's doesn't really have to be a space or a comma. Hello. It's bring your own chair day. Did you bring your own chair? And next weekend it's going to be bring your own instructor.
I'm going to work on that. I'm going to go call somebody who fixes
Oh, okay. Oh, yeah, we were going to take a break as soon as I get to a point where I want to break. Oh, that'd be nice. Thank you. Bring your own instructor day. I should maybe bring your own TA. No, she's here. Bring your own attendance list. Just bring your own everything. All right. So the split function is going to take on this regular expression, split it out, parse it out by its components. Unfortunately, people at home listening to this video are going to be like, why are there so many interruptions in it? All right, parts for the string that don't match the regular expression are valued in the sequence of a list of values. So here we have an example of the split function where we have this line is equal to, what does that look like? It looks like a URL, actually. Looks like a pretty good URL. In fact, this is something that you're going to get, this maybe has been parsed out by some, something that, a path to a file or something. So we have the @ symbol. What does that tell us? So it's an array. And it's going to be equal to split by, well, it says split it by this. And this is line. This is the variable that we're going to split by this. And now we're going to split it out using this colon here as the delimiter. And now the @ fields is equal to Maryland 118, 120. So you can see here. You can actually kind of use it in a very useful way to parse that information. So going back to the reason why we're using Perl, it's an extraction. It's a reporting language. So we can take search results, extract out information. So used for a lot of web processing. Used for a lot of list processing web information. Join takes a list of values and glues them together with a glue string between each one of the elements. So we have the outline, which is equal to join this one with all of those fields, which is going to essentially do the opposite of a split. Join instead of splitting. So Perl functions. Just when you thought there was nothing else more than a language. In fact, I'm teaching you the whole language. This entire video, this entire lecture is everything you ever needed to know about Perl, essentially, outside of modules. And I'll hit that next after we take a break. But we're waiting for our new room. So. Define a user function. So we have a sub with a sub name, statement 1, 2, 3. And it returns the value if the value is the return statement or the last expression evaluated by the subroutine. So calling in a function subroutine here, we have the value is equal to my routine parameters, or as an example here, the @ which is the array is equal to my routine. My routine is the sub function, and we have parameters. This is very C. It is C, actually. It's the same way of calling a function, but here we're using sub instead of, some languages actually use the word function, but it's not necessarily a function. It's a subroutine. So, and that's actually kind of more, this is not a functional programming language, it's a routine-oriented language. So it's, maybe that's why they labeled it that way. Function arguments. So we have the subroutine that invokes is followed by a list of parameters, causing a list of automatically assigned to the specific variable names of each one of them. So the @ for the duration of the subroutine. So _0 is the first element of the array itself, and then the array variable is private to the subroutine. So we can use in combination the subroutine invocation with a list of parameters. And so here's the function private variables. Using private variables inside of functions. So using the my operator. So my operators, it's the same concept as C. It's like what happens in the function stays in the function. So private variables that can be defined in functions. We actually use inside of subroutines. We can use environment variables, we can use global variables, we can use private variables, we can use anything you want, actually. It's very flexible. So, which is very similar to the concept of what you have learned from C. Usually I say whatever. happens in the function stays in the function. But here we have the use of the private variables. My. So my is going to be make the sum a local variable. So my sum. So for each one of these sums, we're going to use this sum as a local variable instead of redefining the variable. So it's the my operator that creates a local variable. It's the same variable actually, which is kind of useful. In C or C++, you're used to passing the parameters, so you would pass that. You would pass sum in here, and you would use sum in there to do something. But you know, the subroutine for add is just going to take sum and use it, and not change sum. So. Semi-private variables. So we have semi-private variables using local. What do I mean by semi-private? Well, you're changing the scope. It's not private in terms of just in that subroutine, but maybe in another area. So local variables are visible to the functions called from within the block in which those variables are declared. So that happens actually automatically. Anything within the same block is available inside of any one of the functions as a local variable. There is no global scope, if you think about it, because the Perl script, it could be combined with another Perl script and another Perl script. So it's kind of interesting how the program unit itself could span, if you use Perl like a glue language, you know, something might be coming from this program over here as input, might be going over there to another program as an output, and it's sort of, you know, in terms of the glue definition, it's sort of a way of merging together, sort of like direction in some ways as well. So variables themselves have interesting scope associated with them. There's nothing really global once you consider the entire operating system as part of the global environment. So requiring variable declarations. So as before we started out this lecture, I kind of said, well, you don't have to use variable declarations. In fact, there's no data types. There's ways of defining variables and using variables as numbers or as strings or something. So programs may choose to require declarations. So if you don't declare a variable and you start using it in C or C++, you get an error message. Obviously, it's strict. But you know, what if you have a script and you have no definition for something? You know, the integrity of the script is completely wrong. The script's going to fail on you eventually. You're not going to know why it failed, but maybe you could do so for error checking. So if you said, well, if you're requiring that this variable be declared and have a value assigned to it before the script will run, then you can shoot a message out to the user who says, hey, you know what? You don't have any search results. Like, we ran the search for you, but nothing came back, meaning that the results were 0. And if you're requiring the declaration, then you can actually enforce that. Do we have another student here? It's bring your own chair day. But she can't fit through the door, that's the problem. Maybe we should take a break. Actually, let's take a break. That's a good point, because there's too many interruptions here. So we'll continue. Let's take about a 15-minute break and reorganize the classroom a little bit. 15? Oh, you know, it's 5 to 12. Okay, hold on one second. Let me end this video so I don't have to irritate these people any longer. Let me stop the video.